All right, today we're going to tackle writing chemical equations from a word sentence in place of a chemical equation, chemical formula sentence. So this, you're going to have to pull on your knowledge from the previous chapter where we were writing formulas and then add that into what you learned about balancing chemical equations. So I have a couple of examples on the board and I'll go through them with you and show you how to do them. Okay, so our first equation, or our first reaction that we're going to be writing says hydrogen bromide reacts with sodium to make sodium bromide and hydrogen. So what am I going to do with all of these words? Okay, well, first of all, I can see some key words in here. Here are the words reacts with, and then I also see the words to make. And so if you recall what I wrote on the board that very first day, reacts with means that I'm going to have a plus sign right there. And the words to make indicate that that's where my arrow is going to go, okay? So an and also is going to indicate a plus sign, so I can see where those symbols go now. So the first chemical that I have up here is hydrogen bromide. So if I have a hydrogen and a bromine, now we have to remember that we have to be careful about making sure that I'm going to be balancing charges. So I have a hydrogen, which is usually a +1, and then I have a bromine, which is in that second to the last column, and it's a -1. And so if I put those two together, I just need one of each. So hydrogen bromide is going to look like that. Reacts with sodium. What's the formula for sodium? Well, that's Na, and that's not one of our diatomic elements, so I'm just going to have just one atom of that. To make sodium bromide, so if I put an Na and a Br, now I think about the periodic table again. What was the charge on sodium? It's in that very first column, so it's going to have a +1 charge. The bromine, which we said just a second ago, it's in the second to the last column on the right-hand side, so it's going to have a -1 charge. So that means I just need one of each of those in order to make sodium bromide. And hydrogen, okay? Hydrogen, that should be on the card that you have with all the diatomic elements on it. Remember, hydrogen never appears by itself. It always appears with a buddy, so I have to have a 2 there. All right, so now I have my chemical equation written. Now I need to balance it. So is my hydrogen balanced? I have 1 on this side and 2 over here. So no, it is not balanced. So now I'm going to have to put a 2 in front of my hydrogen here. Now I have 2 bromines, and I just have 1 on this side, so I'm going to have to put a 2 in front of that bromine. And so now I have 2 sodiums on this side, and I'm going to have to put a 2 on this side in order to make that balance. So 2 hydrogens here, 2 here, 2 bromines here, 2 bromines here, 2 sodiums here, 2 sodiums here. So it is balanced. So now you can see the process. So what we have to do is we have to write each individual formula first. We have to make sure that if I have a diatomic element, I've got a 2 down there. If it's a formula that I know how to write, I have to make sure that my charges are balanced. So once you get all that done, then and only then can you actually balance your equation, okay? Finally, or the second problem here, pentane. Now you would not know what pentane is, so I'm going to give you the formula for that. C5H12 reacts with oxygen to make carbon dioxide and water. So let's look for our keywords in here. Here's our reacts with, and remember we said, well, that's just like a plus sign. Here's our to make, and so that's where the arrow is going to go. Carbon dioxide and, so that and is also going to be a plus sign. So that's where our symbols are going to go. So pentane, C5H12, reacts with oxygen. Is oxygen one of those 7 diatomic elements? It sure is. So I have to have O2. To make carbon dioxide, okay, that's one of those It's made up of two nonmetals, so it's going to be carbon, so there's just going to be one carbon, dioxide, di means two, so it's going to be CO2, and water, and hopefully you know by now that water is H2O, all right? So let's see if I can get this balanced here. So I have 5 carbons on this side. I'm going to need 5 carbons on this side. I have 12 hydrogens over here. I only have 2 over here. How can I make 12? Well, what can I multiply 2 by to get 12? 6. So 6 times 2 is 12, and now I have 12 here. Okay? 2 oxygens on this side. How many do I have on the opposite side? Well, I have 5 times 2 is 10 here, and I have 6 more here, so 10 plus 6 makes 16. What do I multiply 2 by to get 16? Well, that's going to be an 8. All right, so let's double check this and make sure that I have them all. So 5 carbons here, 5 on this side. 12 hydrogens on this side. 6 times 2 is 12 on this side. I have 8 times 2 is 16 oxygens here. 5 times 2 is 10 oxygens, plus 6 more makes 16. So I have 16 oxygens on each side. Okay, so the worksheet that I gave you for today will have a few of these on it. So these are hard, but I have confidence in you that you can do it. Just remember what you learned in the chapter before about how you have to write chemical formulas, and then what you're going to do now to balance the equations out and put those two things together, and you will have it.